Today we will look into the projectile motion. Projectile motion when you throw something through the air. And the only thing that you give the thing is initial velocity. When it's in the air, you're not acting on it anymore. So let's consider if you throw something with initial velocity u at the angle theta to the horizontal. When it's in the air, the only one force acting on it is gravity. So its acceleration will be vertically down, will be g at this point, will be g at this point, will be acceleration g at this point, g at this point. And we disregard air resistance, so there is no force acting in the horizontal direction. So velocity, horizontal component of the velocity, will remain constant all the time through the motion. But in the vertical direction we'll have the motion with a uniform acceleration. To solve such problems, let's choose axis, x horizontally and y vertically. And let's write down the equation of the motion in x direction and in y direction. In x direction there is a motion with a constant velocity, no forces acting horizontally. So resolution of the velocity in the horizontal will be u cos theta, and equation position of the object at any given time will be u cos theta times time. In the vertical direction we often need to take initial position in the account, will be plus u sine theta t. That is u sine theta is the resolution of the velocity into the vertical direction, is a vertical component of the initial velocity, and minus gt squared on 2. So let's consider first the situation when object starts and finish at the same height. And let's find the time, how long it will be in the air. Let's find the range, so the distance, and let's find the maximum height. So let's start from the time. In our case, initial position is 0, and final position when it hits the ground, because it hit the ground on the same height, the final position will be 0 again. So the equation, the motion in the vertical direction will become 0 equals u sine theta t minus gt squared on 2. So u sine theta t equal gt squared on 2. Time cancels out one time, so we get expression for the time, how long object will be in the air. We get t equals 2u sine theta over g. That's the time. Now let's find the range, how far it will go. Let's denote it with L. And that will be position, horizontal position, at this time. So we substitute this time into the equation for the horizontal position. So we get the range equal u cos theta times 2u sine theta over g. From mathematics we know that 2 sine theta times cos theta equals sine of 2 theta, sine of double angle. Using this we get expression for the range equal u squared sine double angle divided by g. That will be the expression for the range. And looking on this expression, we can see that the longest range will be achieved when angle equals 45 degrees. Because when it's 45 degrees, 2 theta becomes 90 degrees and sine 90 degrees is 1, that the bigger the sine can be. So longest range is for angle 45 degrees. Let's find now the maximum height. And because motion is perfectly symmetrical, the maximum height will be achieved when time will be half of the whole time. So we just substitute into the equation for vertical position, we substitute expression half of the time. So we will get that y position at the highest point equal initial height, we took 0, so will be u sine theta times half of the time is u sine theta over g minus g times u sine theta over g, half of this time squared, and that's all divided by 2. So simplifying this expression, we'll get u squared sine squared theta over g minus u squared sine squared theta over 2g. So you get finally expression for the maximum height equals u squared sine squared theta over 2g. So those three formulas that we just derived, they give you time, range and maximum height when object started and finished at the same height. Those formulas for time and range will be you cannot use them if the object starts and finishes not at the same height. But this one that give you maximum height above the starting point, it can be used always to find the maximum height. Let's consider a situation when you start and finish not at the same height. Let's say question is, we have you kick the ball again horizontal with initial velocity u and at the angle theta, and there is at the distance d there is a wall. Question is, at what height ball will hit the wall. Again, approach has to be exactly the same. We take one axis horizontally, one vertically. We again write down the equations of the motion. X equals u cos theta t. Horizontal motion is motion with constant velocity. So that's what we're looking for. Motion in the vertical direction, we have u sine theta t minus gt squared on 2. So most of the time, majority of the time, to solve the problem with the projectile motion, you have to write the equation of the motion in the horizontal and in the vertical. Now we have x, we have a distance at which we're looking for height. So from here, let's rearrange it, let's express time. Time will be equal d divided by u cos theta, and substitute it here. We'll get y equals u sine theta times d over u cos theta minus g d squared over u squared cos squared theta over 2. So y equals u and u cancels out, so we have d tangent theta minus let's write it as g over 2u squared cos squared theta times d. So substituting values, we can find at what height it will hit the wall. And by the way, that gives you, if we replace d just with the x, it gives you the equation describing the path in terms of y and x. So it will give you y coordinates, so the height for any given x. So we can write it as x times tan theta minus g over 2u squared cos squared theta times x squared or d squared here. So this is the equation of this parabola. And it gives you height at any given distance. Now let's consider another example. Let's consider another example. You're at the top of the hill with a high edge, and you throw some stone, ball, whatever, at initial velocity u at the angle to the horizontal theta. Question is how long it will be in the air and at what distance it will hit the ground from the base of the hill. And again we start from the equation of the motion, x equals u cos theta t. Why? In this case we have initial position in y direction. We have h. It starts not from zero, not from the origin. So we have h plus u sine theta t minus gt squared on 2. When object hit the ground, its y coordinate becomes 0. So we will get quadratic equation for time. I will rewrite it making the time squared positive, because it's much less chance to make a mistake when you will be using quadratics formula. So you will get gt squared on 2 minus u sine theta t minus minus h equals 0. We have quadratic equation for time where g on 2 is your a. If you look at the quadratic, ax squared plus bx plus c equals 0. G on 2 is your a, minus u sine theta is your b, and minus h is your c. Then just using quadratic's formula, x equals negative b plus minus square root of b squared minus 4ac divided by 2a. And of course, when we will be solving it, remember that time must be positive. So that's how you find time. And to find the range, we just substitute the value of time that we found from this quadratic equation. We substitute into the expression for the horizontal position, and we will find horizontal position at that time. And one more example. There is a helicopter flying at the height h and with a horizontal velocity u, and its drop package that need to be delivered somewhere. And because again we have only force acting down, gravity, that will be the path of this package. And question is, what will be the distance if the package just dropped from the helicopter? But when it's dropped, it still has its initial velocity u horizontally. So in this case we have angle equals 0. That will make all equations more simple. So we again use x and y. Equation in x will be x equals just ut, because cos 0 is 1. Equation in y will be h minus gt squared on 2. Because sine 0 is 0. So if initial velocity is directed horizontally, that what will be the equation of the motion in the vertical direction. And again, final position y equals 0. So we will get that y equals 0, h equal gt squared on 2. So time equal square root of 2 h divided over g. Substituting it here will give us at what distance it will hit the ground. And one more thing that question often asks you, find the velocity with which object hit the ground. To do that, let's see how the velocity changing through the course of the projectile motion. Again, so velocity in x direction is constant. It will be always u cos theta. As we decided to disregard air resistance, there is no force acting horizontally, and in horizontal component of the velocity stayed always u cos theta. In y direction we will have u sine theta minus gt. And to find, let's say it's hit ground here, to find the velocity here, find velocity means find speed v and angle at which it will hit the ground. Let's say the angle, take angle So to do that, we can use Pythagoras. V will be equal square root of Vx squared plus Vy squared. That will be the speed with which object will hit the ground. And angle, we can use tan alpha will be equal, opposite will be vertical component of the velocity, Vy divided by Vx. So from here we can find angle. That's all for today.